So recordings works, will be recorded, so you can revisit this lesson later. Hopefully it could be helpful for you. I'm getting information from your side, that feedback from your side, that really could be really helpful. Therefore, I'm going to publish it as usual. But today we'll talk about the programming technology, about graphical data. It is part 2, and the agenda for today is still we'll talk about XAML, but XAML, it's not our goal to learn details about this language. Remember, what you must remember, that it's just a language. It is language, so it has semantics, it has syntax, and appropriate alphabet. It is based on XML, but we are using it in the presentation layer, actually in the view layer, because presentation layer we are implementing using the MVVM, model view model, and the view is responsible as a top layer in the presentation layer of the application, and in this layer we are locating all the types that could be used to rendering appropriate information. So let me get back to the question I asked previously, and I haven't got appropriate satisfactory answer. What is graphical data for you? Let me recall that we have applications. This application has 3 layers: data, logic, and presentation. Presentation, in case we are talking about self-contained applications, that is not distributed. It is executed as a single process of the operating system. We need to communicate with the user, and presentation layer is responsible to provide to manage graphical user interface. Additionally, previously we discussed how to organize data to get access to the files and structural data in the database. Before starting discussion about the graphical user interface, let me ask you, what operation must be supported by the graphical user interface? I'm expecting only 3 words. 3 words is required. 3 words is enough to describe what we are doing with the screen from the user point of view, what it's expected by the computer. Of course, presentation we can use also to manage other functionality, for example, communication or API of the application if it's executed as a part of operating system. But I will narrow the discussion only to organization of the graphical user interface. So let's discuss about it in these terms. There's a question about recently I asked the question what technology we are using to solve the problem related to data streams, to manage the data streams. It is serialization, deserialization. We are using serialization and deserialization to convert streams, bit streams, into appropriate objects. Because usually we are using object-oriented programming, therefore we must convert streams and objects back and forth in both directions. Next is managing of the structural data. To manage the structured data, we are using language integrated query. I asked about it many times. And object relation mapping. These 2 techniques, or these 2 solutions it's required to deal with the structured data. So my next question, you don't know what operation must be supported? Next question is how to implement interlayer communication. So I'm waiting for your answers. No, thank you. Now there's time to go to appropriate examples. I'm starting Visual Studio. And I must change the sharing screen, stop sharing, and let me share another screen and reorganize the rest of the screens. Here's it's my Outlook. It is not important for you. For what is important for you, it's external data management. External data management contains all the examples we are using during these classes and contains all the examples that it's enough to accomplish all the tasks during the project. Let me ask you additional question. What is data streams? It is still, I think, we are getting back to the well-known questions. It is good opportunity. Now, I have opened my Visual Studio. I hope you can see it on my monitor. I can see the Visual Studio, therefore it seems everything works. We'll talk about the graphical data. So we have, if you are trying to follow me on your computer, just open the graphical data folder, and in the graphical data folder, you can find 3 projects. We discussed all of that recently. So we have graphical data view. It is a program executable that we can run using. Let me show you how it works. Debug and start new instance. There is a few very important questions related to this graphical user interface. Because today I'm going to talk with you about the communication between the layers. It is main window of this program. So we have 3 buttons and additional windows. And for us, the most important is this button. Clicking on this button, we can see a pop-up that provides the text entered in this box. So here I can provide any text I like, and pressing this button, I can see the pop-up that provides exactly this text. It is good illustration about one operation. I can enter the text, entering information, entering the data, It is one of these 3 operations I asked previously. Okay, next question for you, it is, what is structural data? It's also the topic we discuss over and over, and I must be sure that you know what it is. So entering the data is one of the operation. Clicking on the button, it means that we are triggering an operation. So execution of operation, execution of a functionality, it is next operation. So providing commands. It is actually, it works like a command. So I am asking the program to pop up the text we have in the window below. The same is with this button. It is also after pressing, I am getting a pop-up. Now it is more complicated. There's independent window with many more or less dependent parts. These parts cooperate with each other, so we'll discuss how to cooperate, because it requires communication between the layers. So its second operation is commanding. It's providing the comments. It's entering the comments. And of course, the last but not least, it is to expose the data, render the data. Here, after clicking this button, I ask the program to expose the data. The data, here we can use any graphical representation of the data, drawings, and things like that. Here on the screen, you can see only the check and text checkbox and text numbers. In the windows on the right side, you can see that clicking on the general item, I can provide the details. It is not clear here, but doesn't matter. So exposing, it is the third operation. You must remember, exposing the data, rendering the data is one operation. Second is to entering the commands. So providing orders, what the program should realize, and next entering the data. Three operations that we must we must handle on the screen. It's interesting if you are with me, because this question answered this question previously. So maybe you should know the answer. What techniques are used to manage streaming, structure, and graphical external data? Today I am going only to discuss graphical data, but streams and structural data we discussed previously and answered this. I did answer this question previously, so now it's just a checkpoint if you are still following what I'm talking about. Okay, so remember, you probably remember that starting point of the application is this. Maybe it's not starting point. Starting point, we can find Solution Explorer. Where is the Solution Explorer? Starting point of the application is app.xaml. This file, let me recall, it is partial class that together with the code behind, with this C# class together, creates common class. In this class, we don't have, for example, constructor, but still in the XAML, we are assigning to startup URI, we are assigning new object main window XAML. Therefore, the next operation is to call this constructor, because creating an object, we must call a constructor. Not sure if it works because it is in a different language. No, it doesn't. But still, we can see that we are talking about this main window. This main window, similarly to the previous app XAML, it's together with the C# code, and this C# code has constructor. Together with XAML, both parts create one class. It is one class having two partials, and this partial, this class provides this constructor calling initialize component. Initialize component is a method. So this line, in terms of the language, let me recall that sometimes I am calling you that I am asking you to explain in terms of the language, because here we must deal with different languages, but still all of operations or all of these terms we are using against the language must be more or less, might be more or less the same. Here we have instruction statement that calls a method. It is statement calling a method. Additionally, here we have next method, but this method overrides a base class method that are defined in the base class, and is called by somewhere. We don't know where, but the infrastructure. Let's say it's called by infrastructure. It is strange, and we must explain it. Why? We are using a code with in the code behind, because by design the code behind, so the class C#, this class, should not contain any code, any source code. Main reason is that graphical user interface is hard to test using a unit test. Therefore, a general approach to this is that we are testing the layer below. It is next reason for having layers, that we can test the layers as one whole. And now we could, for example, test in the unit test. Here is a project with test. We can test graphical data project that contains ViewModel and model. So we are not testing graphical interface. Therefore, the graphical interface should not provide any real functionality. But from time to time, it is required that this code should contain something, should have something, should have a very small portion of the code. Because, and we must try to find answer why we need this code. But before answering this question, let me ask the next one for you. I have a problem with getting with the chat window. Where is the chat window? Oh, just a moment, just a second, because here I don't have chat. What happens? It's problem because the chat is not available here. I can't go to the chat window. Maybe this way. Oh, now it's possible. Okay, let's try it this way. So you don't know what technologies? Let me recall. 3 technologies: serialization, language integrated query, and MVVM. These 3 technologies we are using to address any problem related to the bit streams, to the structured data, and to graphical data. Now the question is, in MVVM, where it comes from? Name of the technology. It was used as a foundation. Okay, let's go to the XAML. Still, you don't have question. Maybe there is something wrong with the chat. Can you provide me any chats? If there's any problem, Oh, there's someone that just tries to write something. And I have the next question, but now let's go to the XAML, main XAML. And you can see this file, it is XML document. XML document, it means that we are using semantics of the XML, and we are using also the semantics. For example, here we have an element of the XML document, and the XML says that the name that it's at the beginning of the element and the end and the closing markup, the name of the entering, opening and closing markup is exactly the same. In this case, it is Windows, but XAML doesn't say what it means. What is the window? Here, we should provide any identifier according to the XAML, but according to the XML, but according to XAML, it's not true. Here we can provide any identifier we like. It is limited, it's narrowed. Actually, what we should provide here, we can find in the code behind. In this part, both, as I said, must be recognized, must be recognized as partial class. So actually it is one class. Therefore, looking on the inheritance chain of this part, we can see exactly the same name in the XAML file. Here we can only use the file the class we are inheriting from, and the class the same we can find, for example, here. So the next question for you: what XML and XAML has in common? Actually, I answered these questions. It is next question to check if we are on the same page. What is in common between XAML and XML? I said previously that it is XML document, but additionally we know that it's also the XAML document. If it's at the same time XAML document and XML document, there must be something that both documents, both has in common. Both has in common. Okay. In XAML, as I said, element, it means, go to definition, it means a class. Here, for example, we are referring to the class. And it means that we are inheriting from the class. But what it means, data context? Data context here, window, it means that it is located inside the window class. It is not required that it's located directly in the window, but it must be located as a part as a member inside the inheritance chain. So we must analyze the inheritance chain to check that, go to definition, that the data context, that we can recognize data context as a property. Again, let me stress, I'm trying to use language terminology. Usually it is terminology that is common for all programming languages, for all high-level programming languages. But property is actually something special for the C#. But in general terms related to all the languages, it contains two methods, getter and setter. It is a methods calls while we are assigning or setting or getting the value. So, but its type is object. It is very important that here, if we have a data context is a property, so here we must recognize data context. These three lines we must recognize as assignment statement. So we are assigning to the data context new object of the main view model. Prove it, go to definition. Where is go to definition? It's over here. You can see that it's next class that inherits from the view model base, but still it is a class. Therefore, we are getting access to this class. This identifiers means that we are talking about this namespace located in appropriate ensemble. So it is. It has meaning. If it has meaning, and this meaning is different than the XML, therefore we must recognize XAML as a different additional language. It provides additional. What is the difference between? Let me ask you next question. What is in common? Of course, in common between XAML and XML is a syntax. Both has the same syntax. But additionally, XAML could have XAML could have some limitations, some additional rules that we can apply to limit all possibilities that we have with the XML. So each XML document is also each XAML document is also XML document, but not vice versa. Vice versa statement it's not true, because not all XML documents are XAML document. Therefore, on the top of the XAML document, we are building the XML language. We are building new language. And what is different? Of course, the semantics. The semantic is different, but next question is why? What is the reason we are using? My God, this computer is very slow now. Together with this communication engine, my computer becomes very, very slow. This is what XAML? Why XAML is based on XML? Do you remember? We discussed it recently, a week ago. Getting back to the previous question, what difference is between XAML and XML? Of course, it's semantics. Both are languages, but XAML provides additional semantics, additional meaning. So, for example, grid here means that we are creating a new object of the grid type. Grid type is a class. And now we are referring to this constructor. And we are constructing new object. We are instantiating new object. And of course, this object must be assigned to the somewhere, must be assigned somewhere to make sure that garbage collector doesn't dispose this object, removes this object from the memory. Therefore, we can assume that new object is assigned to the window. So the window works like works like a collection, likes collection or table, doesn't matter. But still, we are assigning reference to new object to a variable, to something that provides windows. Of course, it happens without our direct coding, but it is this functionality is provided by the environment. So environment is responsible to create the object and assign reference to this object to the object above. So here we can see also something like layering, but it's not layered. Actually, we are creating a tree. It's very important that here we can create a tree. So the tree, so the node of the tree that is above can get access to many nodes that are below. But still, the relationship between the nodes are that some nodes are above, some nodes are below. But here the very important thing is that we have tree. Therefore, from each node, it's easy to get to root. Because for each node, we know the parent. And from the parent, we can get to the next parent up to the root. Root is a main window class. It is the root of this tree. It is very important. It is very important for communication between binding, because, as I said, we must provide three kinds of operations. We must render something on the screen. It is the first operation. Second operation is it could be static or dynamic, what we are rendering on the screen. Second, it is to enter the data from the user side using appropriate user interface. And third, it is to execute the commands. To do it, we are using binding. What is binding? What is binding? But in the language terminology, for example, here we can find binding. Let me point out on this screen places where we are rendering dynamic and static data. Second, we are entering new data from the user and executing commands. Here you can see the text box is a very good place to provide render dynamic value. The value must come from somewhere. It must be a data, and this data is converted to the picture on the screen, must be converted to the picture on the screen. This kind of rendering we call dynamic. But static, it is to render the text box on the screen. You can, from the previous example, from running the code, we can find all places. Not sure it's possible to, for example, here we have a picture. Let's try me to put it in the middle on the screen. And here, for example, we have text. You can see that after clicking on the text here, a part of the window is selected, and we can see that it is just a line, just a border of this box, but still it's rendered. We call it static rendering, and having appropriate flexibility of this language and this environment, is also possible to change the shape. We are using template or shape. We are using to expose part of Actually types, because as you can guess, text box, it is F12, provides help us to find a definition. Is just a class. It is just a class, but this class could be rendered on this screen. Therefore, answering the question what the view should contain, what types we should gather inside the view layer, the answer is all the types and only the types that are rendered, that could be rendered, that we are using to build the graphic on the screen. So it is static, because the type is could be rendered on the screen, and there is the dynamic, because text, it is a property of text box. We are assigning a value, and we must assume that the value could change during the execution of the program. Therefore, following the new value, we should expect on the screen new value, rendered new value. But to render new value, rendering of something on the screen requires an operation that must happen. Something must be executed. For example, if there is a number, we must convert this number to the string, and second, the string must be exposed on the screen. So we must talk about the fonts, about the parameters of these fonts, about the color, background color, foreground color, and similar things. But it's rendering. But still, to render something, we need to deal with the dynamic value. Of course, all the types, including this grid, including even this window. We can see on the screen that the window is rendered. We have a name. We could have many parts additional. For example, we can here add menu. We can add here change colors and shape of the screen. So many things could be, many features of this screen could be customized. Still, it is rendered. So static and dynamic. Dynamic means that we could change the value of the text property. Third, it is to trigger a comment. The best, it's a button. Of course, button, it's class. F12 goes to the class, so we can prove that it's class. But it is class rendered class. Therefore, we can see, for example, here a very simple shape of the button. Selecting this button, or for example, this button, doesn't matter which button we are selecting. On the screen, we can see a blue frame that points out where the button is located, where the button we can find on the screen. Therefore, we can recognize this type as renderable. It's possible to render also this type. Next, content. Sorry, content. It's just a text that we can see on the screen. So, for example, here we can change everything, and it is monitored on the second window. But for us, the most important thing is dynamic behavior of the graphical user interface, so that during the runtime I can press the button. Pressing the button means that I'm executing a property. Executing an action. Executing an action. So the problem is how to select this action, and if this selection is static or dynamic. Of course, everything must be dynamic. So during the runtime, against this change of the state of the whole program, for example, a button could change first the shape. Sometimes sometimes should be impossible to press the button because the state of the program is not ready. It's not, so the program is not ready to execute a command. We must wait for something. We must wait for some events that to change the state of the program to make possible pressing a command. Let me show this example. So again, I'm executing the program. It takes a while. Maybe in the meantime, I try to ask you next question. Second, I'm popping up a new window here, and the question for you, it's complicated. So before going forward, let me read it and explain. Button command previously discussed. Is it unidirectional communication? So only clicking is possible on the screen, or so it's yes. If no, it should be possible to use the bidirectional communication. So to explain, let me go back. Here, for example, we have a button and it's a command. So actually, we can assume that pressing on the button, we could execute a method. So I don't have this question, but previously I asked you, what the communication, because the communication, it's something that the term defined outside of the language. How to express these terms in terms of the language, this meaning in terms of the language. Of course, usually communication. It means that we are calling a method. If one part of the program communicates with another part of the program, one object try to communicate with another object, it must call a method. Calling the method is almost the only possibility. In this language, additionally, we are using properties because properties contains methods. Actually, two methods, getter and setter. Both behaves independently. So calling the setter or calling the getter, we are calling a method, and as a result, we are assigning a value or we are getting back the value. Of course, it's also possible to assign to variables new value. It is also the communication, but it is special communication. We're trying to avoid this communication because if someone that assigns this value to the different part of the program, there is no way. There must be additional functionality that we are using to trigger. We are using to inform the target of the value that something happens. So button, is the communication bidirectional or unidirectional? Of course. Let's stop this discussion. Maybe next question for you. Maybe you know. There you are very silent. I don't know why. What type should be aggregated by the view model? Previously, I asked about the view. Now the question is about the view model. What type should be aggregated? If you still needs activity points, be active and answer the question. So this communication is unidirectional in both. So we must recognize communication in both direction. An example you can find in a program I started here, not in this part, but there is another. Oh, here. For example, here you can see, maybe it'll be, no, I don't try to do it. Hopefully you can see it. So here we have two buttons, show tree and browse. You can see that show tree view is now, it's great. It is not active. I cannot press it. But after pressing the browse reads something, do something, executes a method, and after that, the next button is active. So clicking the first button, the result of clicking the first button, the result is that the state machine changed the state. So there is an event that can be used to change the state. After changing the state, it makes active next button. Therefore, we can see that as in the text, we can see dynamically new text, but here we can see dynamically new features of the button is active and the color changes. Therefore, we must recognize that but the button and this command allows us bidirectional dynamic behavior of the button. To provide this behavior, actually we must talk about the communication, because as previously I said, we are still trying to answer the question what type should be aggregated by the view model. Now let me change the question. What mechanism is used by view to notify the view model about the necessity to execute a command? What mechanism? Remember, in terms of the language, don't try to use any free language. Now you must be precise. What mechanism is used by the view to notify the view model about the necessity to execute a command? So there must be so the view must do something that as a result the operation happens. The behaviors we are expecting take place. So first, we must answer the question where it happens. Where should be implemented the behavior? If you are implementing a behavior, it must be tested using the unit test. It must be tested using the unit test. Of course, it must be located not in the view layer, because view layer by design is not unit tested. And therefore, we must all the functionality related to the controlling, to the managing of the state of the application, state of the user interface, must be located in the view model. So the answer, what type should be aggregated by the view model? The answer is all types that is responsible to manage the state of the user interface. If the state changes, after changing of the state of the interface, we need to provide back the information from the view model to model, for example, as in the button. all the execution of the command and result must be located somewhere in the view model. Of course, there's the question about next question. You don't know binding? No binding, because binding is not term of the language. Binding is not term of the language. I know it's hard. Binding, we can find, for example, here binding. What is the binding? F12. It's a class. So in terms of the language, binding is a class. But binding is a class, and actually here is not a class. Here it is F12 to make sure that you can notify it. Binding is a constructor. So we are creating new object. Here we are creating new object. After creation of this object, the reference must be assigned. Reference must be assigned to the parent object. In this case, the parent object is a grid. It is the parent object. Parent, it means that we are part of the tree. So the button is located as a node in the tree. And the grid is a parent node that contains, for example, these three buttons and this text. Therefore, talking about the binding in terms of the language, we must answer that it is a class. Talking about the language, about what mechanism is used. Let me ask next question. What type should be aggregated by the model? We haven't answered this question, so it's up to you. Try to answer this question. What type should be aggregate? Should be added? Should be we should add to the layer, add to the set of types that we can call as a model layer. Of course, what mechanism is used? Method call. It's only possible, as I said previously, it's possible way to execute something, because the method means that we are executing something. Let me check the time. Okay, we have still couple of minutes to discuss, to prove it. So now we can recognize that binding is a class. Actually, it is constructor. So we are creating a new object. Of course, this assign character, this assign character doesn't mean that we are assigning reference to this binding to the command, because the command is expected, F12 is expected that the object of I command is assigned. Where is I command? Here, for example, we can see that go to definition. It is a property. It is a property that actually returns I command as a value. It must be assigned here. It must be assigned probably here. In the constructor, we are assigning, so to this property, we are assigning reference to a new object that calls rely command. Rely command is a typical implementation that we are using to implement communication between the layers. And actually, implementation of the I command. It is typical implementation of the I command. I have provided, designed this class here in the program, but it is also available in many frameworks. So binding actually has access. Binding as an object could have access to two properties: command property and this property, shown through tree view main window command. So doesn't trying to understand all the details. Here we are using, for example, reflection. We discussed reflection previously. We are using reflection, and actually binding could have access to two objects that refers to this property and to this property, and this class, this object, during the runtime of this object, is responsible to transfer the data from this property to this property. In text, here in text, we are transferring the data from this property to this property. Let's try to find this text object. It is this text object. You can see that providing new text here, the text comes from this property. Go to definition. You can see that it's property having appropriate getter and setter. So while we are starting, we are getting the value from this variable, and this variable, it's this starting value, the entering value of this variable. We can find here. We can find here. So we are assigning it to the to this action. To this action, text actually returns this value, so we can observe on the screen. But it's static. Still, it's static because it's at the beginning after starting of the program. But later on, it must be dynamic. So all modification of this property action text must result as a new value on the screen. Must result on the screen. Actually, we are writing on the screen, but under the cover, we are writing to the memory, and back the value it's on the screen. Back on the values on the screen as a dynamic value, So no, we are not. So the environment doesn't copy directly the text. It is copied as this mechanism. So binding actually this object observe any values here and try to assign this value to the text after modification. But the problem is how to do it, because actually we have two possibilities. First possibility, it is to pull, to check if there's something new in this property. So the binding could, for example, in a loop, never-ending loop, could check if we have new value. But of course, it is not very smart. In the meantime, I try to ask you the next question. What kind of delegates you know in terms of the language? Of course, it's stupid. It's stupid because we are wasting time, because we are trying to execute operation that we can avoid. Actually, we can avoid this this operation by signaling, by sending a signal from the layers when the action text is, go to definition again, from the layer when this property is defined. It is in the main view model here. Action text. So after modification it means that we are assigning to the local variable. But how to send signal to the view model? We haven't access to the layer above. Now we are in the view model layer. Therefore, it is impossible to call a method. So try to keep this terminology that signaling or communication in all of the cases means call a method. We cannot call the method from the view model because it's impossible to get access to the types from the view model. We are in the view from the view, because now we are in the view model. We are in this DLL, but this DLL doesn't have dependencies on the graphical data view. Therefore, here, let's check again. We are over here, so we are inside the graphical data, but we cannot call a method from the view because the layer below is must not get access to the types that are located in the layer above. So having in the view model all the types that control the behavior of the screen, and in the view all the types that we can render on the screen, we could have in the model here in this layer, we could have all the data that it's necessary to be exposed on the screen, to enter all the values from the screen. So it is intermediate layer between the view model that implements behavior of the screen and the rest of the program. Usually in the software, in the program, you have also the data layer. But data layer is responsible to provide all the types that we need for the program as a one whole. But in the model, we are gathering only types that we need to provide appropriate data on the screen. It is the main. It is huge difference. It's huge difference. Therefore, for example, here you can recognize that first, the main view model. Now we are in the view model, so we are in the layer below, and we are going to signal the layer above the view that something happens. Actually, that we have assigned a new value. We are after assigning new value, we can call this method. This method needs more information related to the button, but go to this definition, we can see that this definition this method is located in a class that is a base class of the view model. So all the view model classes should inherit directly or indirectly from the view model base. View model base inherits iNotify property change. This interface provides definition. Go to definition. It provides definition of an event. So the question is, what is the role of an in terms of the language? What is the role? Get me back to the previous question, delegates, and recall the delegates, for example, we have two. And delegates is also here. Here, it means that we have a type. Go to definition. It's a type. We are defining a type. We are defining a allowed set of allowed values. Set of values we can use. In this case, it is set of all of the methods, reference to the methods that have this signature together with the type return. So we can define a type against method function. If we have void, it is just a method. If there is a type, we could have a function that returns a value. But in this case, it is limited. Where is, okay, I've closed this. It is located MVVM Lite. Yes, there is a MVVM Lite, there is a framework, but I'm not using any framework here. The program doesn't use any framework here. The names also, the names only calls. It is by accident similar to the framework name. ViewModel base, it was the base class that must be inherited by all of the ViewModel classes. And here we have an event, and it is also it is a common point between the ViewModel and view. And what it means that we are, what is the role of the event? The role of the event here is to collect references to the method. It is a type, it is a variable, it is delegate, it is also delegate. Delegate means that it's type or it is variable. Event additionally says that it is impossible to call the methods that we have gathered, references we have gathered in this variable as a set. So the call of this method is possible only inside the class. It's impossible to do it from outside of the class. And now we are calling. Now we are calling this method here. We are invoking this method. Okay. Next will be how to prove, how to use it. It is the next point. So we'll get to the unit test. Hopefully we'll have time. But let's go back to this, not to this, but to okay, to the solution, to the main window, to the code behind. Main window, code behind, and we must explain why we need something like that. Probably you know that here we are dealing with dependence injection. We have discussed it many times, and here it is very important point where we are using this functionality. From the data context, we are getting the reference to the main window model. In XAML, previously we recognized these three lines like assignment to this data context, new object, reference to new object, main view model. And here we are reading this reference. Creation of the object happens inside this method. This method is marked as unavailable because it is auto-generated. And now the method actually doesn't exist, because if it will be generated, it will be auto-generated during the runtime. is not auto generation during the design time. Therefore, during the design time, it doesn't exist. But after running the software, the method will be created by the tool, by the framework, by the WPF, Windows Presentation Foundation. That is the answer to the previous question, where the MVVM comes from. It was born by WPF, Windows Presentation Foundation. Therefore, we must assign that it's dedicated pattern to be used as a presentation layer. So assigning to the data context happens inside this method. So actually, we are converting the XAML file, we are converting to the C#, but additionally, it is converted in at runtime and is converted by this method. Therefore, here we can read the value. So after reading the value, it is the method is overridden, and we know from the description that it's called after creation of the object. So first constructor is called, and after that on initialized method is called by the framework. So we are obliged to call back the base class instance, the method from the base class, and next we are getting the value and assigning to this object, to the properties. Here we are assigning, for example, this message box. Why it is required here? It is required here because we are getting access to types that has graphical meaning, so could be rendered, and these types must be located only in the view model. Here, this type and this type, both types must be located in the layer, in the view layer. Therefore, it is very it is real error if we are trying to create objects of these types in the layer below. Additionally, we are using lazy, so it means that this delegate will be called if needed. After we call appropriate, we need this reference, so this type refers to the delegate, but it returns I window only. In child window, go to definition, you can see that it is getter, but it refers only to the abstraction. It is next example how the dependency injection works. So in the layer below, we are using only abstractions. We are not referring to the types that must be used only in the layer above. So here we are assigning lazy with the based on the as the generic type as a parameter I window. It is abstract definition to make sure that you can pick definition. It's interface. So it is abstract definition and is located in a view model. Okay, so what is the last thing I need to discuss with you? Let me go to the there's many very important things, but let me go to the tree view. Can you see here, for example, it is also, we are also in a view layer, and this type doesn't contain any, in the code behind, doesn't contain any additional additional code, but very interesting thing it's here, because here we have two buttons, and one button, as you can see, it is not active. Is not active. Let me switch to the both views. Oh, yes. Now we can see that we have two buttons. Browse is active. This button, browse, is active all the time, but this button is not active. Why? Go to definition. Because this property, it is also a relay comment. You are assigning to this show button the relay comment here. It has two parameters. First parameters, add root, is a method that it's called after clicking. So it is, let's go to definition, execute. Again, execution and calling, triggering any action, it means that we are executing something. We are executing a method. Delegate is also a method. It's also a method. So here we are assigning to the execute, we are assigning a delegate. If it's null, an exception is thrown because it's not expected. It must lead to a real method. It must lead to the real method. If it's null, it is wrong, because after clicking of the code, we should expect execution of the method. But additionally, the view can change, the view can check if it's possible to click the button. It uses next. It uses a method, can execute, and in this case also it is a delegate. So view is calling a method from here, from this relay command, but this relay command implements interface I command. So after clicking, it executes this method. But to check if it's possible to click the button, if the button should be active on the screen, the view can execute. Next, again, we are using an abstraction. Additionally, it's possible to signal the view that can execute that the value of this method changed. Again, we are using event. So after we should expect that after clicking a button, we are changing possibility to use additional action, and after that we should call all the methods that are assigned to can execute change. As the result, the view model could use can execute to make sure that that the button should change on the screen. View model XAML, and for example, we are using browse. So after clicking the browse, the state of the show tree windows change. So let's go to this definition, and here it is still a comment. It is still a comment, and we have a relay comment, and we are using browse method. Go to definition, says that we are assigning. Here we are assigning to the path variable. Assigning path variable, it is a property. So after assigning a new value to this property, we can call rise can execute change from the show tree view command. So assigning a value to a property, we can use to raise an exception to trigger a method from the view to signal the view that the view should review possibility to use a button. This way we can organize any state machines, and we can use the state machine. We can synchronize, harmonize this state machine together with the state of the Windows. So as you can see, the only possibility to for the communication between the layers, we are using calling the methods. If it's impossible to get access to the type because the type is located in the layer above, we can use events. So the layer above could assign a value to the layer below, and the layer below could use abstraction, could use the common definition to execute any operation that is assigned from the layer above. This approach we are called IOC. It is inversion of control, because we are calling something from a different part of the program, in this case in the layer above. Still we can use the layers, still we can use the rules that the layer above could have access only to the layer below. Thank you very much for today. I am switching